Ladies and gentlemen, I would like to welcome you warmly to this webinar, a webinar that is organized by the World Bioenergy Association on the use of agricultural residues as fuel. Today we want to look at what are the latest technological developments, what kind of technologies are available to use agricultural residues as fuel directly by combustion. And we have a number of distinguished speakers here to give you a first-hand experience on what we can do even today in using these agricultural residues. Let me briefly introduce myself. I'm Christian Rakosch. I am the president of World Bioenergy Association and also the manager of the Austrian Pellet Industry Association. We have about 200 registered participants in this webinar, participants that are coming from all continents, participants that are coming from very diverse backgrounds, from companies, from universities, from international organizations, consultants. So a wide variety of persons that are interested in this subject. I find that very encouraging that we are having so many visitors and we're having really a global presence. I apologize for those that are having to view this webinar at awkward times, like our friends in Australia or maybe in Asia, maybe not so happy with this timing because, or the friends in America, they will have to get up very early to attend this, but it's very difficult if you have a global-ish webinar to do it at the right time. We want to have an interactive webinar. For this purpose, please use the Q&A button at the bottom if you want to ask questions to our presenters. We will also use a couple of short little polls to get some information from your side so we understand better what is of relevance for you, also with respect to making a series of webinars, so not just this one, but also the following ones, to get some information from you. Where are your specific interests? With that, I'm going to hand over shortly to our next speaker. It's Mr. Hong Hao, coming from China. At the moment, China for sure has the most impressive program to use agricultural residues as source of energy. And Hong Hao is both vice president of the World Bioenergy Association and also the chairman of Great Resources New Energy, a company that has realized a very significant number of large projects in China using agricultural waste for energy. So with that, I hand over to Hong Hao. Thank you very much for being with us, and please give us your presentation. Please share also your screen. Hong Hao does seem to have an issue with the connection at the moment. Let's wait for a moment. If he is not able to come in again, I would probably ask Lars to continue. Let's just give him a chance to reconnect. And if that doesn't work, Lars, would you be ready to work through your presentation?
Yes, very much.
Excellent.
Just say go.
Then let's give it a go. Lars, you are the CSO of Justsen Energiteknik, a Danish boiler company that has over 30 years of experience in big biomass boilers. The floor is yours. Please give us your presentation.
Thank you very much. Are the slides visible on the screen now? Yes, they are. I can see. Hello to all from Denmark. I'm pleased that so many are logging in. I can see the numbers here on the screen. We have a lot to cover. I have 8 to 10 minutes, so I will jump straight in. I won't spend so much time on doing the presentation of the company. People can read that in the slides. We have an agreement that when I raise my hand, I would like to change the slides. So please go ahead. Yeah. Houston is a group of companies over the world. We are a so-called original equipment manufacturer and OEM based in Denmark. We have, as you rightly say, 30 years of experience with large boiler plants. But in total, we have more than 60 years experience with biomass boiler plants. And we celebrated our 60 years anniversary last year together with technical partners from all over the world. We are working as an OEM, but through these technical partners and our own 3 subsidiaries in Australia, Estonia, and in Denmark, we can offer turnkey solutions to end users worldwide. Please switch to the next one. Here we have a slide showing where we are represented at the moment. We are here today to talk about mainly agricultural residues. So I will quickly move on to the next slide. We have now 3 slides and we have decided to provide an overview of the characteristics of some representative agricultural residues. And we have, for comparison, wood chips from virgin wood to see where the agricultural residues mainly differ. On the next slides, we will show some of the challenges, and on the next again, we will show some of the solutions that biomass boiler providers are using when combusting agricultural residues. So first of all, the key characteristics, you can see there are 4 columns on this slide. The first column shows virgin wood biomass, and what is marked with yellow on the screen is the challenge we see. The good thing about wood is that carbon, hydrogen, and oxygen together is about 99% of the dry matter in that type of biomass. It's very easy to handle. I'm not going to talk about wood. It's there for comparative purposes. Instead, I'm going to talk about straw, crude olive cake, and rice husk. And we have chosen those 3 because they each represent different challenges to for fuel purposes. So if we start with straw, you can see on the second column that it is relatively high in sulfur. It is relatively high in nitrogen and chlorine, and it can be very high in potassium. Furthermore, straw has a low ash melting point. It becomes sticky at quite low temperatures compared to wood. And another thing that is special for straw is that it's often delivered in bales of various forms. It can be Heston, it can be mini big, it can be meaty, it can be round bales, providing some challenges that I will get back to. Then in the third column, we have crude olive cake, which is a residue after olive oil production. What makes that special compared to straw is that it's quite low in oxygen. And where wood is typically 43% of oxygen, and rice husk and straw are also quite high The problem with crude olive cake as a biomass fuel is that it has a very low volatility. I will get back to that later. You can also see at the bottom row that it's quite sticky as a fuel. Finally, the rice husk, it's extremely high in ash content, 13 to 23%, according to the examples provided in the ISO standard. It's quite easy when it comes to these elements like sulfur, nitrogen, and chlorine. It's quite like wood, so that is not really a challenge with that. But the high silica content in the ashes is quite challenging. Also, it's quite low in density, so feeding it in can be a challenge. So I'm ready for the next slide to go more into detail with the challenges. Here you can see the fields that were marked in yellow on the previous slide. Here we explain a little bit what the challenges are. Let's forget about wood for now and focus on the agricultural residues. If we have straw, the medium to high sulfur content results in SOx emissions, but also corrosion issues inside the boiler. When it comes to nitrogen, it's also quite high, although not as high as contaminated wood wastes like chipboard and MDF. It has as the only one of these, a high chlorine content, and that results in hydrogen chloride and dioxin emissions, and also corrosion issues. And that is true for many agricultural residues. It's high in potassium. Potassium is used as a fertilizer, and when it's combusting, a percentage of that potassium becomes K2O, which is quite sticky at low temperatures. So that creates fouling issues inside the boilers. Straw also have a low ash melting point, so there can be slacking and clinkering on the grate, and that again can create some fouling issues. But maybe the main thing about straw bales is that you need to debale them into a uniform fuel, and that is not an easy thing to do, because you have two ways of debaling. You have a straw cutter, which is sometimes used, but it's a very dusty environment. So for medium scale and large scale boiler plants using straw, you want to have a dust-free environment, and that means that instead of cutting it into small pieces, you have to shred it instead. So you put the bale through a straw shredder, and then you, on the other side of the shredder, you want to have a very uniform fuel so you can control the combustion. Because if it's two big chunks of straw coming through, you will have issues with lack of control of the capacity of the boiler, of the temperatures inside the boiler, but also you can have an incomplete combustion of the straw because the combustion air can't get to it, so to speak. I'll try and speed up here a little bit. Let me go to crude olive cake and focus only on where it differs from straw. You can see on the slide that it has a low volatility, large percentage of fixed carbon, low oxygen content. So you need a more rectangular grate to completely combust this olive cake. Furthermore, as we saw on the previous slide, the physical properties is that it's quite sticky, so it tends to build up in conveyors. Moving on to rice husk, there are large quantities to handle, and the fly ash with high silica content is quite abrasive on the heating surfaces of the boiler. Let's move on to the solutions. If we, instead of going by fuel, go by the rows, we'll start with ash. The ash content of straw and crude olive cake is quite high compared to wood at least, but for rice husk, it's extremely high. And that's why you need special conveyor systems. A fifth of what goes into the boiler comes out as ash because of this high silica content. When it comes to the low volatility of the olive cake, you need this rectangular grate. When it comes to sulfur emissions, sometimes lime injections are used. Around the world. There are different levels of SOx emission allowed. On the EU directive that came out in 2014, a limit was set for 300 milligrams and 200 milligrams, depending on the size of the boiler. And that is marginal for sulfur dioxide emissions. So in some cases, you would need to use lime injections. I will get back to that on my last slide. The nitrogen content results in NOx emissions, as we saw, and there are different ways of controlling that. First of all, you need to avoid creating the nitrogen oxides. When it comes to biomass, all the nitrogen in the flue gases will come from the nitrogen in the fuel and not the nitrogen in the air. So it is fuel-derived NOx that we are looking at most. Good boiler design with staging of the combustion air can ensure that you are not creating a lot of it, but you can also employ, depending on your construction, SNCR or SCR systems to inject urea or ammonia to the flue gas stream and keep the level down. When it comes to chlorine, then on this slide, I focus on the dioxins. Dioxins are normally not part of emission to be kept for biomass classified boilers. There is an exception in France where they have some local legislation where you need to keep the dioxins down even for biomass boilers. We'll get back to that on the last slide. With chlorine, it's the same as sulfur, it's corrosive. You need good boiler design to do that. And one of the key things to do is to keep the water temperatures high. Use high-grade steel, like stainless steel in the ignition zone or in the economizer to keep it down. Moving on quickly to potassium, it becomes sticky at quite low temperatures. And therefore, compared to wood-based boilers, you need to be lower in the temperature before you reach the narrow passages inside a boiler. So that's why they are often designed with large empty chambers to lower the temperature to, say, 650 degrees before it enters a narrow boiler tube. The ash shrinkage starting temperature, well, we use water cooling and we have a high pressure drop through the grate to ensure that the combustion air is where we want it to be. Physical properties, we have the debaling, it's good design. The build-up of olive cake, it's good design. And with rice husk, with the silica contents, you need to have replaceable wear and tear parts inside the boiler. I'm ready for the next slide and I will try and speed up. Quickly going through this slide, Grøngas is a customer of ours in Denmark. It's built as a straw combustion plant and it has been in operation for 3 years. The straw, the harvest in Denmark 3 years ago was not of a quality that was good as fuel. Therefore, they actually switched there to crude olive cake on that boiler, and we have learned a lot from that to deal with the high sulfur and with the stickiness of this fuel. And I'm ready to move on to the last slide. This is a newly developed boiler system that we have made, and you can see on the slide here that we have employed some of the things I've been talking about earlier. First of all, you have the water-cooled grate that is fully integrated with the rest of the water system inside the boiler. In the ignition zone, we have stainless steel reinforcements to make sure that the activated chlorides and sulfur is not going to cause corrosion. We have vertical passes, and on the third pass you see marked there, it's a chamber for employing a SNCR system because it needs the right temperature window in order to reduce the NOx emissions. And then where it's pink all the way through inside the pressure drum, we have empty passes with good space. We have discharge orders, so we don't have fly ash lying on shelves inside the boiler to prevent dioxide creation. Then it goes through the pressure drum and through the economizer, which would be modulating. And when it's modulating, we can actually control the flue gas temperature to hit the sweet spot of the lime injection after the boiler system and before the bag filter. And moving on to the next slide, I would like to say thank you. I of course take questions. You're always welcome to send us an email, and I hope I didn't go too much over time. Thank you.
Thank you very much, Lars. That was very good to start with. So that you gave kind of a generic view on the issues and the challenges, and I think that was very useful for the rest of our presenters who will not need to go into these generic issues. And now I'm very happy to introduce Hong Hao to you. Hong has been the chairman of the vice president of World Bioenergy Association, and he is also the chairman of Great Resources New Energy, a company that is realizing a significant number of projects that are using agricultural residues as fuel in China. Hong Hao, the floor is yours.
Okay, thank you. Things we all know. Okay, things we all know by September 22, our President Xi have announced that our China have our target that by the year 2030 we will reach peak emission, and by the year 2060 will reach carbon neutral. So based on this target, China have policies to improve biomass energy heating supply. Especially we have a 5-year plan from by the year 2021 that will use bioheating as much as 2.1 billion square meters in whole China.
Sorry, how would you like to share your screen with us?
Yes.
Okay, very good.
Okay.
Yes, just do the full screen mode, and then we're good to go.
Okay, okay.
Thank you.
This is resources what we have in biomass energy. Our biomass resources are much as 2 times compared with hydrogen, and also 3.5 times as wind energy. That is means our biomass energy is the #1 in renewable energy resources. And the important issue is look at the right paper that our biomass energy located in eastern side of China, which is 75% of people who live, as compared with the solar and wind energy, which is located in western side, which only 25% of people live. That is biomass energy resources is compared with our energy consumption. And we also have enough biomass resources because we including forest residues and agricultural residues and other organic resources. And this is the forest residues what we have in whole China. And this is a different kind of agricultural resources in whole China. And this is a market based on we have 650,000 boilers in whole China to produce heat. And right now, 85% of these boilers still are coal boiler that use coal. Only 1 to 2% of the boiler based on biomass. So we still have a lot of potential market. And as we're talking about the market, first we need to analysis about the industry manufacturing who use heating. And the number one is chemical in China. The chemical industry use as much as 34% of the heating in whole China. Number two is petrol. As we calculated this, I think this figure could not be calculate whole China energy consumption of heating, but some of them, only some of them, is as much as 586 million tons of coal equivalent. That is 146 billion yuan every year. So this market is big enough. And this is industry heating. Another heating market is urbanization. You know, in China, we have more than 1% of urbanization growth every year for past 10 years. So even in the building heating need is very high. As we analysis, first we have to thinking about the quality of the analysis when we talking about to use biomass energy. That industrial analysis, including these elements, and ash melt heat value element analysis. And we have set up quality analysis labor for 55 years before. And we also have some standard, national standard to do the quality analysis. And this is the result when we're talking about the pellets. It's including wood pellets and straw pellets, especially corn straw pellets, and also rice husk, peanut shell pellets. These are the 5 top we use in Northeast China. And these are the chemical of agricultural residues elements. And this is 3 challenges. One is fluorine, another is sludging, the third is corrosion. So when we're talking about agricultural residues, when we use, we have to face these 3 challenges. And also, another challenge is the cost. Based on our experience, straw pellets is nearly equal to the coal consumption. The cost is similar. So wood pellets a little bit higher compared with the straw pellets. That's the reason why we are trying to go into use agricultural waste to make pellets, because that's the cheapest choice for us. And the emission, that's the 3. One is coal-fired boiler, one oil-fired boiler, and gas-fired boiler. We have to compare our biomass boiler to meet the emission demand. And right now we don't have a national emission standard in whole China, but in some province, for example, Jilin province have our own standard of emission of biomass boiler. And during the past 15 years, because we set up grid resources by year 2006, we have set up a value chain from resources to the plant service. And this is our business model. One is BOO. That means we invest a heating plant to supply heat to our customers, and we buy pellets from the resources owners, and we will give our technology to make pellets, and we use their pellets to heating supply to our customers. Another business model is EPC, that we do everything to service our company. And now we have so many customers, and at least five of them are the top 500 enterprises of the world. And this is a case study. This is our smallest boiler, which can supply heat from 50 square meters to 300 square meters. And the best advantage of this small boiler is it could use straw pellets. And this is the biggest plant that we have already used. That is, each boiler is 56 megawatt, and we have transferred 5 these boilers from coal fire to pellet fire, and it's running from year 2015 to now. And this is another case study that we use rice husk pellets from year 2017. That is university zone that we supply heat to 10 universities, as much as 1.2 million square meters. And this is another case that we use peanut shell pellets to supply bio-steam to our customers. And this is a CHP plant that we use corn straw directly to produce heat, to produce electricity, and to produce also fertilizers. And this is another case that just finished this by early this year. It used wood chips to produce steam. So, and this is another case that we use briquette of corn straw, also to use hot air to dry the corn. That means we use a straw of corn to dry the corn. So now we have our plan to trying to use the bioheating to supply carbon neutral town, carbon neutral industry zone, carbon neutral cities. This is our target. And but right now we are trying to use any advantage technology to reach that target, not just in Jilin province, but in whole China. So this is the year we are trying to do the planning for the next 5 years, and we want to use most of our resources should be based on agricultural residues, because in China, #1 resource should be agricultural resource. And based on our more than 10 years experience, we can use it smoothly. So that is my report. Thank you very much.
Thank you very much, Hong Hao. Thank you. This was really amazing what you're accomplishing and the way that you're growing the use of agricultural residues. There has been a question in the audience, a question that I also was, initially I also was really surprised to hear. You were mentioning that using pellets from straw are actually competitive with coal. And the question from the audience from Jean-Marc Josard from Bioenergy Europe was, would it be straw from wheat or from corn?
From corn, not wheat, because in Northeast China, we only have corn. But I think for wheat, that should be similar.
Okay. And it is indeed so that it is possible to realize a conversion from coal to pellets without a subsidy, or would what would be the incentive? That there was another question. What would be the incentive for a coal-fired boiler to be converted? What is going to be, how are policymakers going to introduce this change from coal to agricultural residues?
First, for the policies that coal boiler could not be used if the capacity is lower than 14 megawatt. So every coal boiler minimum than 14 kilowatt should be shut down. So that's the chance for us to do this. Second, when we transfer from a coal boiler into pellet boiler, we have to change a lot. So now we push that we use a new boiler instead of coal boiler. But the case that I just mentioned is that boiler too big to transfer. And although we can successful from coal fire to biomass fire, but the outlet should be shut down a little bit lower than before, than the coal fire before. So this is two. And the third question is, we have no subsidies. We just running based on 100% commercial. That means our customer pay everything, no other subsidies. The reason why we can reach this, because when they use coal, the efficiency is quite low. You know, in China, we have less and less coal. So the quality of the coal is bad and worse. So the efficiency will quite be low compared with our biomass boiler. Another issue is the coal-fired boiler cannot meet the demand of the industry customers' need, because the heat load is always changing for the industry producers. But the coal-fired boiler could not meet that, could not change that flexible. But our biomass boiler could meet that demand. So we use a less amount of fuels compared with coal. So that's the reason we can earn money.
That's extremely interesting to hear. So there are also technical advantages in using a modern biomass boiler compared to an old coal boiler. Yes.
Yes.
There was one more question, and then we'll go on to the polls. And that is, what is the proportion of the coal? You mentioned, I think, 650,000 coal boilers. What is the proportion of these boilers that could be theoretically be replaced by biomass?
Just now I mentioned that the first step for us is for the boiler lower than 14 megawatt. Step by step, maybe by the end of 5 years later, the boilers, coal boiler should be as much as 40 tons. That means 35 megawatt. this highest heat load coal-fired boiler should be shut down. That means most of these 85% of these small size, in China we call these small and middle size boiler should be shut down instead of, and biomass is the #1 choice because it's cheap enough, and also we have enough resources to instead of coal.
So there are enough biomass resources to replace all of these boilers with biomass boilers
right now. But I think in next step, we need import pellets, import the biomass from other countries, I think in future.
Okay. Quite impressive. Thank you very much, Hong Hao. That was extremely interesting. And I would like to now go over to two little polls that we have been preparing to better understand your views, the views of our participants. And I would like to ask Bharadwaj to come up with poll number 1. Can you share? The poll number 1 is looking at the interest of you, our participants. Is your interest, what kind of forms of agricultural residues are you most interested in? Are you more interested in the use in small scale applications or in large scale applications? Are you more interested in the use of solid fuel for heat and power generation, or more interested in the transformation to liquid biofuels? Or are you basically interested in biogas, because that is also a way of using agricultural residues? You can select several of these topics. This is just to understand a little bit of where your interest is. So just tick those points you find particularly interesting. You can select as many as you like and then push the submit button. And we'll wait for a few seconds. Please just tick the boxes you find most relevant, submit the results, and Bharadwaj is going to, our Secretary General is going to share the results with you shortly. How many responses do we have already, Bharadwaj?
Yeah, we have quite a few. I think I'll share the results.
Yes, share the results. Please do so. So that is interesting. We have a little bit more interest in the use of small scale applications than in the use in large scale applications. That's interesting. We have a majority of participants that are interested in the use as solid fuel for heat or power generation, not so much into transformation into liquid biofuels, and a little bit more into biogas. So even 40% of our participants are also interested in biogas, which means that this could eventually be also a topic that we look at the further in a further later phase of this webinar series. Thank you. That was very interesting. So that gives us a good idea of where your interest is. And let's go to the second poll, Bharadwaj. So the second poll is looking at what aspects you are most interested in. Are you most interested in the current research and development, or in the status of technology development? Are you interested in the experiences that are there with using agricultural residues, or more in the policies that are supporting the use? Are you interested in the economics, in the logistics, in the densification issue? There are a lot of different aspects of using agricultural residues. So please tick those boxes you find particularly interesting, so we have an idea on where to push this, the content of this webinar in the future. Just tick the boxes that are relevant for you and tick the submit button and we'll look at the results. Bharadwaj, can you share the results with us? Very good, thank you. So 31% are interested in research, 60% about in technology, status of technology development. So I think that corresponds quite well with this time's seminar. Experiences are even greater of interest. So what are the practical experiences? It's a good hint that this is the point we should really focus on. Policies are of interest, economics, logistics less so, densification a little bit higher, but the focus of interest seems to be really in sharing the experiences. So that is also a very interesting result. Thank you very much for this. And we'll keep on now going with the next speaker. And this is Gediminas Venkus. He is Chief Commercial Officer of Enerstena Group of companies. Also a group of companies that has been really successful in putting out bioenergy use in the Baltics, but also in other countries. Gediminas, the floor is yours.
Thank you, Christian. Hello, everyone. Good morning, good afternoon, or good evening. I will conduct a briefing of our activities and our accomplishments when it comes to agricultural, specifically agricultural fuels used for process steam for industries or for district heating applications or for heat and power. And I will proceed promptly now with, I don't have, okay, now it works. Giving a prompt summary about the company itself. For those who are interested in numbers about the company, giving an understanding of who we are, what we do. We are a team of around 200 people, company established 20 years ago, out of which around 15 years and more have been dedicated for continuous R&D in developing technologies, scientific research, improvements of existing technologies, and so on. We are present today in 10 international markets, mainly in Europe. However, we are also looking into other regions. There are also developments outside of Europe. And the absolute majority of our employees are qualified engineers, which give you an understanding that boiler business is not about plumbing or welding. Of course, those parts are there, but it's essentially a product or a solution of highly qualified engineering skill. And so I come to solutions. I'm talking about solutions rather than technologies here because our final customers are looking for and they are aiming for energy, right? They don't need boilers, they need energy, whether it's steam or hot water or power. A boiler plant as such is just a black box where the fuel goes in and the valuable energy goes out with some byproducts like flue gases, ash, and so on. So I would prefer to talk about solutions rather than specific technologies, where actually Lars Houston has introduced and gave a very nice summary of some properties and challenges, how they can be overcome. And in this light, I can also say that there is all of the solutions are there in the market. If you look up, we have all of the solutions needed for agricultural biomass. Yes, there are challenges, but there is no essential thing missing in the value chain of technology supply. It's both down to the technological islands in the plant, but also on the level of the whole solution that requires certain adoption, certain modification and improvement in order to adopt the plant for challenging fuels such as agricultural fuels. And when it comes to our portfolio, we operate, our portfolio comprises 3 parts. We produce and then supply water heating plants, process steam plants for industries, and combined heat and power plants. And for water heating plants, we operate up to 50 megawatt per plant, where the fuels are locally available biomass fuels. By this I mean to say it's starting from wood, which is very conventional and easy to handle. We all know that, but we rather dare to say that we will focus the solution on the fuel that is locally available, whatever it is, and whatever challenges it brings. I can tell you that yes, there is knowledge in the market that knows how to handle that. That is not an issue. For process steam plants, where typical, so for water heating, a typical customer would be district heating or utilities, as we call it. Not very often, but sometimes also hot water is needed for technical processes, perhaps for drying and so on. But it's a rare case. I would say most often we see district heating as or centralized heating as our customer. For steam plants, we're talking mainly industries, and here we like to focus on those that have byproducts or residues or waste, biomass waste from their processing, from their production, and we redirect this waste back to the production in the shape of energy. So we turn their waste to energy. This is a wonderful concept that I think every technology supplier here at this panel is using, and it enables very many advantages and brings a lot of value to those customers who go for it. Here the capacities can be up to 60 tons per hour of steam, which is more than enough to cover absolute majority of process industries. I'm not talking about perhaps pulp and paper or other large-scale industries that requires somewhat different solutions. And the heat and power plants, unfortunately, I must say that typically and normally this only flies if there is a subsidy in place. However, the solutions are there. The technology supply industry is ready and will step up if there is an opportunity. Fuels, agricultural fuels, yes, they introduce some challenges. However, it is not something major that would prevent projects fly. But again, either a carbon tax or a subsidy of other financial incentive is mandatory to make this fly as a business plan, as an investment, to make it economically feasible and bankable. And just to illustrate a couple of examples of our projects, I'm not going into very narrow, very deep technical detail here, primarily because of confidentiality restrictions that we have from the customer side. They do enjoy a lot those investments, and it brings certain competitive advantage. And in many cases, unfortunately, we're not allowed to disclose the types of solutions and what has been implemented. So this gives you a very broad overview and gives you examples of what kind of industries are running our plants, where are they located, and what is the type of fuel that they use. So in the left top corner, we have rapeseed oil mill. They're producing rapeseed oil for cooking, for food. Yeah, and their steam demand is 5 megawatts, 6 to 7 tons, depending on the present capacity of the factory, and they produce a lot of agricultural waste or biomass waste. Before that, they used to dump it, and they dump it to even landfills, and some of it goes back as a fertilizer. However, there are some challenges with getting rid of that material. So what happens here is they burn it and they will produce process steam. Flow of biomass, however, in this plant is not enough to fully cover the steam demand of the plant. So they will mix in some waste wood also to complement the availability of biomass that is needed for steam supply. Another interesting example, this is actually a one-of-a-kind plant worldwide, first precedence worldwide, where our customer will produce xylitol, which is a substitute for sugar. It's a sweetener, comes as a substitute for sugar for food industries, and they will extract it from oat husks that have been already processed in whichever way is possible to process as for the purpose of food. So there is a flow of oat husk from mills, bakeries, and sorting lines, and so on in the plants that they are running. They will extract xylitol from this material, and there are some really sophisticated chemical processes involved. They will treat those oat husks with sulfuric acids, and I'm not allowed to comment in very fine detail, but however, the byproduct out of this process is the fuel that we will be using to supply steam for that exact xylitol factory. A very interesting, very, very unique plant where this kind of fuel actually literally doesn't exist worldwide. And it's a challenging one. There are no practices of using this fuel globally, and we're really happy to have been selected as a trustworthy partner to supply the energy plant for this customer. Another example, grain flakes and probiotics. We mainly from also oat husks, but also other types of grain. So oatmeal and grain meal is very trendy. Everyone is enjoying healthy breakfast, and these industries are actually growing, and they produce side streams. So reject of grains and oats, oat husks, and so on. This is a wonderful fuel. It has some challenges, of course, but while this stream of fuel is available right there at the plant, it is absolutely efficient and effective to use it for energy production, which is consumed here and now at the same exact plant. Another example, we have several projects for greenhouses in the Netherlands, also in our region where we are based, in Lithuania. Greenhouses basically have a very seasonal operational period, and they harvest and remove old plants. They bring in new plants. They have greenhouse bedding, which is coconut, comes as a coconut fiber that gets exhausted after a while. They need to get rid of that. It depends on technology, of course, of the greenhouse. However, this is all usable as a fuel for those greenhouses when the season is down, when there's cold outside, they need to supply heat into the greenhouses. Here we have 5 or 10 megawatt or something in between of hot water heating boiler plants using that residue from this agricultural industry. Another one-of-a-kind plant for us, and also very few of these examples exist. This is not agricultural, actually, this is bone meal. Our customer is processing meat. So they extract oils, produce feedstock for animals and other types of products from animals that were killed, dead, or it's a factory that actually processes and dead animals as waste, if it's fair to say so. The byproduct of this processing is bone scrap and bone meal that is no longer usable for any kind of feedstock. They either are not allowed to do that, or it's technically already exhausted enough that there is no value as a fuel, as a food, and they will use it in 100% as 100% fuel to produce 3.5 megawatt steam for their own factory. This is a new project also for us to be finished in 2021. And finally, buckwheat processing, another example. It's a small plant, 1 megawatt, but still it's a one of a kind also for this type of industry. Buckwheat processing, they are steaming and drying buckwheat and do some processing of the grain. As a product, they have buckwheat shells, a flow of buckwheat shells, and that we in turn will fire and supply process team. So you can see this is only a few recent examples. I picked more interesting ones where we are using agricultural or origin biomass fuels to supply energy for industrial customers. There are examples also in district heating. However, in our region, mainly we have seen woody biomass, which is not so exotic. And today we'd like to speak about agri-foods. Now about the potential that agri-biomass residues brings to the stakeholders. There's absolutely untapped potential, huge potential of agricultural fuels, and we believe it very much. And the key message from technical perspective from my side is that, yes, the technology is there. We have, or the industry has technology solutions for all of those fuels. What we would like to see is more encouragement from those stakeholders to move forward in that direction. And by doing this, they will recognize a handful of values, or we can say that biomass waste to energy enables several valuable aspects there. So energy independence. If you can disconnect from your gas pipeline, coal, or heavy fuel oil, or so, you produce your energy from your own side streams. This is really wonderful. So in terms of supply and cost, you become independent. Your product becomes more competitive. You get a sustainable business. You're no longer dependent on the imported fuels, right? There is circular economy also in play, a very popular term that is frequently used. If you manage to use it in the right way, marketing-wise, and position yourself, there is added value that comes not so explicitly, but you have to smarten up to use it, and customers certainly already recognize this. Carbon neutral manufacturing. This is growing very much on industrial agenda. Certainly, customers are recognizing that. And green profile, altogether, all of those. You get a green file of your company, of your product. While today, I can tell you that this can be seen as a competitive advantage, and some companies are successfully using that. However, in several years from now, I think you will extinct from the market unless you are carbon neutral, unless you use the circular economy principles, and unless you do have a green profile. So our wish and belief is that industries that are processing agricultural materials, they must transform themselves into using wastes and byproducts that are not usable as food, as fertilizers or so. We're talking about waste and residues. They have to transform themselves in the coming years. Technology, again, I will perhaps not deep dive. Actually, Lars gave a very good insight there. I couldn't agree less on the solutions and challenges that we see with agricultural biomass. But the message is, to round up, is very, very prompt and clear. We have the solutions.
Great.
The solutions are there.
Thank you very much, Gediminas. That was a very encouraging presentation. Yes, please all feel free to also directly get into contact with Gediminas. In view of the time, I would like to skip the questions in this case and proceed to the poll. And the next poll really relates to what Gediminas has been saying. It relates to the question, what are the barriers? What are the barriers that keep us from doing this, as it makes so much sense and as the technology is seemingly available for the most different tasks of using bioenergy from all kinds of different sources. It was really impressive to see, Gediminas, how many completely different types of feedstocks you're actually able to use. So may I ask you, Bharadwaj, to come up with the next poll, please? Yes. Which forms? No, that's not the right one. The next one, please. Oh, I can see the question is wrong, but the answers are right. Sorry about that. The question is, which are the most important barriers for using bioenergy? And the answers is, well, low cost of fossil fuels, lack of awareness of the opportunities, lack of political support, lack of adequate technology and know-how. Well, technology seems to be there, but maybe know-how is missing, lack of financing for the necessary investments, logistic issues, concerns regarding possible environmental impacts. So please ignore the question you see on the top. The real question is, which are the most important barriers? So tick the boxes you find that are important barriers to bioenergy use at the moment and submit your answers. All right, let's see what the results are. Low cost of fossil fuels, lack of awareness of the opportunities. That's interesting. So the most quoted reason or the most quoted barrier for using bioenergy from agricultural residues is the lack of awareness of opportunities. To be honest, I think that is exactly the scope of what we want to do with WBA. We want to contribute to the awareness of the opportunities of bioenergy, and that answer of you all suggests that we are on the right track with that target. So thank you very much for this. And with that, I'm going to hand over to our next speaker. And there have been a couple of questions asking about gasification and why is not gasification being used? Well, the answer is it is being used. And I'll hand over to Mr. Garay. He is a sales manager of Polytechnic company, another company with a long record of building biomass boilers for different fuels. Mr. Garay, the floor is yours.
Thank you very much, Christian. I will share my presentation. I hope you can see it. No. Good morning in the United States, good afternoon in Europe, and good evening in Australia. It's a very interesting presentation. I would like to start with a short introduction of our company. We are a family-owned company in Austria with around 250 employees and more than 3,000 references all over the world. From 1965, and our latest project in New Zealand for Christchurch, 15 megawatts. We have also plants in Europe from 1 megawatt, and the range what we can is from 300 kilowatts to 30,000 kilowatts. You can see some details of the company. We have 8 different combustion solutions, from waste wood to bark and agricultural waste. We have several power plants with electrical production, cogeneration, regeneration, and turnkey project also. One of our burning system is the polyhate, high efficient and low dust combustion. This is a gasification system, as you asked in the on the list. It looks like we have this part is a gasification, and we have a second part with the burning chamber and the boiler. The function of the system is we have biomass in the gasification system. The upper part is fresh material, wood chips, corn stalk, wheat pellets, sunflower shell pellets, and in the second part we burnt this gas from the gasification chamber, the burning chamber. That's because we can achieve very low dust emissions. We use the fresh biomass as a filter system, and this burning chamber achieve 5 to 20 milligram dust emission without any other filter system. You can see how does it work. It's a normal gasification system. At the bottom is the runs the gasification, and the upper part is the fresh material. We have also a moving grate, and everything is the same as the usual biomass boiler. What makes it interesting that we burn the gas and the flue gas or the biogas or in a second part of the system. That makes it very clean. Now we have some small ones from 400 to 1,500 kilowatts, but we also have bigger solutions until 30 megawatts. What's very important is this kind of technology can achieve 90–93% of efficiency with these low emission limits, what I mentioned earlier. Even with pellets, we can achieve 94% efficiency. This is an emission measurement after 2,000 working hours without a cleaning system, lower than 5 milligram after the burning chamber, before the chimney without a filter. We have some references in Austria. The first one is a smaller one with 400 and 600 kilowatt. It's a new technology we started this year. We have 5 references so far, and you can see the fuels what we tasted or what we have with this boiler. I think the most interesting is the corn cob. It so far not used in the US, in Russia, or even in China. There is a huge amount from corn cob in the world, and we can also burn it with this technology. Every kind of agri pellets, straw pellets, sunflower, miscanthus. We have very good test results and reference plants with these fuels, and of course wood chips as usual. Every kind of wood chips with waste wood or bark or lower quality. We have a second burning system is for straw burning. With this kind of burning, we have a water-cooled burning system. The walls are overall water-cooled. We keep the temperature low. We have a little bit different moving rates for straw burning, and the same boiler for warm water, steam, hot water, or even thermal oil. We can use with the system sunflower shells, straw or rice husk. We have the first reference plan is a smaller one in Austria with 1 megawatt in Stetteldorf. You can see it. We have a fully automatically storage system with a straw, fuel handling, and the filter. It's the AutoCAD. This is the normal burning system. There we need a filter, a backhouse filter for the low emission limits. There are some pictures from the stove based from the fuel handling system. This is the furnace with this water-cooled walls, and the normal boiler with automatic cleaning system. There you can see the fuel handling. It's fully automatic. It works fully automatically. Thank you for your attention.
Thank you very much, Mr. Garay. I think it's really amazing what you are achieving. I mean, 5 milligrams of dust without any flue gas cleaning. That is a fantastic achievement and shows the strengths of the gasification aspect. There was a question, where is the electricity production part? So can you answer that?
Yes, I can answer it. Basically, if somebody hears gasification, then the second thought is, okay, we are going to produce electricity. No, we don't. With this system, we have also power generation plants, but with this small gasification system, we wanted to burn the biogas was not only from food. We wanted to burn immediately after the process without cooling, without gas filter, without washing system, and all these complicated parts. We wanted immediately burn it and achieve only these low emission limits for warm water, for steam, or for hot water production.
Thank you for that explanation. I mean, this is something that I find really important, what you're saying. I mean, very often there's so much focus on electricity production and nobody takes into consideration how difficult, technically speaking, it is to upgrade the flue gas to a point where you can actually then use it as a fuel in an engine. So the solution that you're showing is addressing the largest market, which is the heat market, in a very simplistic design, which allows to get rid of all the flue gas cleaning and then use a very high efficiency.
Yes, yes, exactly. And just last words. We have also a solution for power generation, but I think power generation makes sense if you have at least 5 megawatt electricity, and you can use the rest of the heat in a district heating system. And for small system, I believe in small systems, but mostly for heating, not for electricity.
Thank you very much. Thank you very much for this. And before we go to the last speaker, one little short poll, one final poll. Bharadwaj, can you be so kind and show the last question? Yes, the last question relates a little bit to our work as World Bioenergy Association. And the question is, how should WBA support the use of agricultural residues as energy source? And there are a couple of possibilities to answer. Offer an extended series of webinars. We have started with that. Edit a status report. Do you think that is important? Establish working groups for selected topics. Organize an international conference on the topic. Enhance the awareness of policymakers for the opportunities of agricultural residues. Produce video documentations of successful cases. Which of these answers do you find are particularly relevant? Just tick the box you find. That's a good idea. I would like them to do that. And we'll get the feeling for what kind of things you find are important to take this issue of agricultural residues as energy source ahead. So please tick your boxes and submit your answers. Bharadwaj, what are the answers? Where are we? Okay, so you feel the most important activity is to enhance the awareness of policymakers for the opportunities of agricultural residues. Good, we'll try to do that. We are present in a number of international forums. Most importantly, the Conference of Parties, which will take place in Glasgow by the end of this year. And this will be a good opportunity for us to follow this advice. There is quite a good response on the idea of the webinars. And we also see a pretty good response on the idea of producing videos that document successful cases. And we have been engaging, we have been starting to engage in the production of such videos. And you will be able to see the first couple of videos already now in our website. Fine, so that was the last poll, and now I'm handing over to Kenneth Iverson. He is the CEO of the Weiss company, which is part of the Linke Group, another company group that is active in biomass combustion units. Kenneth, the floor is yours.
Thank you very much, Christian. I have the agreement that we're not controlling the slides from here, so I raise my hand and we move on. First, I would like to say I'm very excited to be a speaker at this seminar. It's an important issue in the green transformation at our world, and I'd like to say hello to people watching and participating from east to west. Could you go to slide 3, please? Yes, drop that. Thank you. So I would like to, I think that Mr. Gediminas came with a very good point at this, that I won't go into chemical issues here and in detail. I would like to go up in the helicopter and take a look at it. This is about having some residues, agriculture residues. It's about an energy need all over the world, and the solutions are there. It's just to pick the right one to the fuel. And it's about experience and know-how delivering that. And as Linke Energy, Linke Group, we can do that. Linke Group consists of 3 companies. The 2 of them are located in Denmark. This is Linke and Weiss, and Jernforsen is located in Sweden. We have a very wide product line of product to agricultural residues and burning this to obtain some energy. And yeah, we believe our technologies are state of art. We have our own service organization because we believe it's important that we can support all the way to the after delivering the project. Yeah, and then we guarantee an efficient incineration and with various types of biomass. Yes, please, the next one. Our values is very important for us working with this area. We would like to see ourselves as very responsible, and we are providing credibility, and we would like to cooperate. Cooperation with the customer, the future customer, is very important for us. Yes, please. The next one. And quality. Delivering quality in all phases of a project is also important. And as group, we work on our quality system all the time to improve, to give some value to our customers. Yes, please. The UN Sustainable Development Goals. Yeah, you talked about one of your polls. There was a barrier for using biomass as an energy source. And we think if we work with the UN goals, we have to work political. And this, I believe, is very important as one of the major barriers in this process of having green transformation. We work with these four every day, all year long, to improve a better world. Yes, please. So our business model is boiled down to, we would like to see ourselves as a consultant to the customer. We help you decide which product you have and what the solution is. We develop the product together with you and to be sure that the need you have is covered. And again, we have the support all the way, also after we delivered the project. Yes, please. Technology. What we deliver is we have a hot water plant. We deliver high pressure hot water, steam, and we also have combined heat and power system. I think it's exciting to see the polls you make, Christian. It's observing how the response are by the people, but one of them was small scale biomass. That was one of the topics, coming from solid fuel and experiencing using agriculture residues. All these three parts are something that we as a Linka Group can deliver as a part of a project. Our combustion is also world patented. So yes, please. So project management is also, as a project, very important. So we customize the solution, we design the solution to our customers, of course, in close collaboration and again, based on their needs and requirements. We use 3D drawing and we calculate budget prices compiled of all documents. Yes, please. I mentioned it earlier, support is very important. We believe it's important that customer will get the support quick after we have delivered our project. We have an in-house inventory of spare parts by day-to-day delivery, of course, due to where it is in the world. We have internet access to all our installed plants all over the world with remote support. So you have availability all the time. Yeah, and we have support 24/7 all year. Yes, please. And you can skip that also. So solutions. It is so that here green energy in Denmark has been a topic the last 40 years. So the transformation have started here in Denmark a long time ago. That's why we're very experienced in designing and installation of biomass solutions, and especially agricultural residues. We are very good. We have boiler size from 250 kilowatt to 20 megawatt. When talking about biomass, we have also learned due to experience that fire extinguisher equipment is very important to risk backfire. And all our boilers can be prepared for installation of SNCR, as a DENOx and dust installation as emissions control is very important for us. And this is of course fitted to the plant itself and to the need and the regulation in the where the customer is located in the world. Yes, please. We also deliver a mobile solution. You don't have to be a stationary one. If you have a need for a mobile temporary solution, we actually deliver a lot of those installed all over the world. Of course, also as a turnkey solution. Yes, please. Fuels. As you see here is our fuel range. And we have our own test facilities in Denmark. So at the moment we are testing rice shells from a customer in Japan to see how does it develop in combustion phase, how is the emission, how does we have to scale the boiler and all the combustion line to that. If you can see, I would like to say that straw burning is one of our very experienced fields of fuel, and that going down from 1 megawatt up to 20 megawatt. We have installed a lot of straw installations, and that mainly in Europe, but also going to the United States at the moment, where the market is developing very fast. And then, yes, please. And our references, we have just picked an example or two. And Skamby here in Denmark, wood chip and grain waste with a 90.4% efficiency, and the carbon reduction per year is, as you see, over 1,000 ton. So it's 1 ton and 30, sorry. It's process steam, and it's a 2 megawatt facility. Yes, please. We have Hornsyld Købmandsgård. I believe for some of you that this is a bit difficult to read, of course, but waste from grain, 2 megawatt, hot water, installed in 2017. The boiler burn 14 tons of waste from grain every day, equality to 50,000 liters of oil that has been saved in that process. Yes, please. At the moment, we are installing this straw-fired biomass plant here in Denmark also. It's a combined plant with a biomass boiler and a heat pump. And we see the market for heat pump here in Denmark and Europe is increasing. So this type of combined energy plant is, for our sake, looking very as a demand for the future installation. So what we believe is the plant will generate 100% carbon neutral heat. It is so with straw that it is a circular process. When the straw is growing on the field, it's absorbing carbon. When we burn it, of course, we create carbon, but it's equivalent. And the waste from the combustion ash is spread out on the field, on the farmers as a fertilizer. So there is no actual waste from this process. Yes, please. And in Sønderborg Forsyning, we have an operating 10 megawatt hot water installation providing district heating. It's been set in operation just this year. And as what we see now, the emission is very low, and there's not installed any DNOx or SNCR on this installation. So it is possible to obtain low emission without any further installation of DNOx. And the last installation is in Hungarana in Hungary. We have installed a tree-lined straw facility with operating temperature of 220 degrees. flue gas temperature of 120 degrees, and this is they're using this for operating process, so making steam for the factory process. It's very reliable, and the customer is very satisfied with that installation here. We are operating at this facility with 16 bars of pressure. Yes, please. Yes, our motto is we are with you all the way. And as I mentioned, we would like to see ourselves as a consultancy. We develop together with you and we support you after installation. Thank you.
Thank you very much. That was Kenneth, that was a very nice presentation, and also showed, I think, together with the other presentations, and that's to me the main takeaway of this webinar. The solutions are there, not only the technology, but also the service, everything that comes along with offering a real solution. So talking about using agricultural residues as fuel for energy production is a real possibility that exists around the world, that can rely on very well developed technologies, technologies that are extremely clean and extremely efficient. It's just amazing to see what has been achieved over the last decades in technological progress in using this fuel. So with that, we are coming to an end of this webinar, but certainly not to the end of our series of webinars. All of you are going to receive a follow-up mail with the link to the presentations that you have seen, and also to the recorded presentations of this webinar. So you will be able to share this webinar also with colleagues that want to see it. It will be on our website, and we'll be very happy to welcome you in the next edition of this series of webinars. We'll invite you to this. Yes, a last thing that I would like to say before we close this webinar is, you can see that there is a scope of promoting bioenergy. There is a scope for the activities we are doing as World Bioenergy Association, and we would very much welcome as many of you as possible as new members of our associations to kind of improve our strength in communication and in taking the message of bioenergy out into the field of policymakers and of course into the wider world. So thank you very much for joining. Bye-bye, and hope to see you in our next webinar.
Bye-bye.